Okay.
It's just so he can blend in with the rest. Yeah.
So, in the past, right, I've used phrases like limit from the right, limit from the left, right? And so what that means officially, right, or, mathematically, means that x approaches c from values that are greater than c. Okay, from the right, right? Because to the right of something in a number line, right? To the right of something, those values are greater. So if we're approaching c from the right of c, that means we're approaching from values greater than c. Okay? The way we denote that, we say the limit as x approaches c, okay? And then in the exponent position of the c, we put a little plus sign. Okay? Limit as x approaches c from the right of f of x, and we'll just say it equals, I don't know, some number L there. Okay? So that's the notation we use to indicate approaching c from the right, from values of c greater than c. Okay? And so then you can probably figure out what the limit from the left we're going to write for that. Okay? It means that x approaches c from values that are lesser or less than c. Lesser wouldn't make sense. Less than c. Okay. And the notation for that is c, limit as x approaches c with a negative sign in the exponent position. Okay. You have to be especially careful when you're reading limits. If you're doing them too quick, you might mistake seeing something like this and thinking that you're trying to evaluate the limit as x approaches negative c, right? You might just see this and transpose the negative in the c, just a little mathematical dyslexia there or something. Okay, so just be careful, right? If the negative is in the exponent position, you're approaching c from the left-hand side. If the negative is in front of c, right, that's the negative c that you're evaluating there. Okay, so two different things. Okay, so let's try here. So we'll do an example. I'll have you guys try some. All right, so we'll say evaluate the limits we'll do the limit as x approaches 3 from the left of x squared minus 3x plus 1. Okay. So the good news is to evaluate a limit from a particular side, left or right here, we can still use direct substitution, right? We can still plug it in, all right? Especially for this function is nice and continuous, right? It's x squared minus 3x plus 1. It's a parabola. There's no jumps, holes, gaps, asymptotes, anything like that. And so we can just see what happens as x approaches 3. Approaching 3 from the left, well, again, since the function is continuous, we know the left-hand and the right-hand limits are all going to be the same, right? So approaching 3 from the left, we just plug it in here. 3 squared is 9. Minus 3 times 3, so minus a 9. 9 minus 9 is 0. Plus 1 gives us just 1 there. That's our answer. So direct substitution works here. Okay. Then we take the limit as x approaches 3 from the right of that very same function. Okay. And what do we get here? What's our answer? 1. Yeah. It's going to be 1 again. It must be 1 again. Okay? She's like, Mr. Whitmire, why don't you even bother with this stuff then? It would just mean the same exact thing as the limit as x approaches 3. Well, hold on to that thought, right? But for right now, yes, it does look like it's the same thing. And it's that way because this function that we're looking at is continuous. Okay? It's continuous everywhere. And so therefore, any left-hand and right-hand limit, okay, corresponding left-hand and right-hand limit of a number, right, are going to be the same. They have to be because the limit must exist everywhere on this function, again, because it's continuous. And so we're not going to see any interesting behavior here. So then let's see what happens when we have a more interesting function. Okay? So just as a little side note here, for a continuous function, use direct substitution. Okay, so there's nothing new there. You can just plug it in. Okay? Let's look at another more interesting function, though. Let's say we have f of x, and it's equal to x squared minus 5, that quantity, and 2x plus 5. And it's for these arguments. Okay. So here's another piecewise function. Okay. And I'm going to give you guys something to try here. Okay. So find the limit as x approaches 1 from the left of f of x. Find the limit as x approaches 1 from the right of f of x. Find the limit as x approaches 1 of f of x. And then, are you okay, Hayden?
No.
Do we need to give the Heimlich over there or something like that?
Please. I think I'm good now.
Okay.
Yeah.
If you need to get a drink or something like that, you just let me know. Although I guess if you're choking, you probably shouldn't try and drink more, right?
Yeah. I think that would be bad.
Yeah. Okay. So go ahead.
Math safe.
There you go, right. So give those a try, all right? Ponder those a little bit. Take a look at those. I'm gonna go right back on this. Make some copies here, some drafts. That I forgot to do.
That would have sucked. These are different. No, that was Isabel. Maybe it's second.
No, it's less. Because that means it approaches from the right. So if it approaches from the right.
That's when it's from the left, so it's from the first function on the second.
Even though 1 is not less than 1.
Yeah, well, it's what it's saying is as it goes towards the one to the left. Then the second one says as it goes towards the right, because there's a function. But then if the third one says what?
What?
Just call it 1. Like,
No, I just like went outside and bought.
No, basically, I was like,
One is gonna have to
it was like, I want the 1 point as like a black column. But then I was like, I'm not willing to spend $60. I was like, I'll just go with 4 point.
Yeah.
Wait, okay, let's still be negative 4.
on your head.
So this last one versus second one, say do you go?
Well,
So,
no.
the third one is, does not exist.
Not every day.
Because you have two functions.
So how do you know
Okay, so for number one, it's saying, what is, like, what is x, what is y, is like x is approaching one.
But it has two sides, so.
So number two, and the second one's saying it's approaching the right side, because there's different functions on different parts, like it's a piecewise function, so if you're equations, they're not gonna be in the same spot. Like the numbers that they're approaching from each side are not gonna be the same. So when you have the third one, which just says x versus one, it doesn't exist.
For the second one,
Does that make sense? Yeah.
So wait,
it's gonna be less than one.
They're really good.
so for this first one, the answer will be -3.
But deal on a daily basis.
So for the second one, the answer is going to be 7.
You sub one and you sub it and you have to look at the domain.
This was a one.
In the last one, it's using an x
So this was 10.
And then like so 5 is the second equation says x is greater than or equal to 1 for 2x plus 5, 2 plus 5 is that. And then negative 5 is less than 1, so plug in the first one. You have to
Yeah,
write
you-
one.
Yeah.
Really good. He was in the 90s.
Yeah, -4 is
She babysat me somewhere after 5th grade.
Hey,
That's
I'll
weird.
help you.
Yeah,
Yeah.
it was funny.
She wasn't a very good teacher. She only cared about 13 colonies played.
But Ollie, what do you type in?
13 colonies.
Seven.
Put it in so that x is greater than.
Anyway.
Seven.
Make copies. All right. So, use these here.
Oh, wait. You're not like, you can just survive on the internet.
We'll go over right now. Okay. Okay. Woo. Okay. Number one. What do we say there for number one? Ideas? No ideas?
For what?
Yes. -4. Okay. How did you decide that it was going to be -4?
Well, since like, I think it was like x is approaching the -1, so like on the second part of x, like x is less than 1.
Uh-huh.
It'd be the first one because -1 is less than 1.
Okay.
Just plug in 1 in for the first equation
Yeah.
to give you -4.
Okay, exactly right. Yeah, so we're approaching 1 from the left. Our piecewise function here changes, it switches right at the x value of 1. If we're trying to approach 1 from the left, that's from values less than 1. So we're going to use, that matches this inequality here, so we're going to use this part of the inequality. And so yeah, then you could just do the direct substitution at that point. And so we get 1 squared minus 5, which is negative 4. Exactly right. Okay? So that would be your answer there. Okay? Good job, Madison. Yeah. All right. So then number 2, right now that Madison's explained it, right? So number 2, we're going to approach 1 from the right. And so that means we're going to be using which piece of our piecewise function here? The second piece, right? And we plug in 1 there. 2 times 1 plus 5. Okay, so that's going to be 7. Okay. So the limit as x approaches 1 from the left, negative 4. The limit as x approaches 1 from the right, positive 7. The limit as x approaches 1 then should be does not exist. Okay? The left hand and the right hand limits do not agree. So the limit does not exist overall. Okay, the left hand and the right hand limits must agree. So that means at 1 is this piecewise function continuous? No, right? It can't be. The left hand and right hand limit disagree. All right. Number 4. Limit as x approaches 5 of f of x. What do we do here? Anything special? So, yeah, plug it in the bottom one. Exactly right. Yeah, bottom one, because our x value here is 5. That's greater than or equal to 1, so we're going to use the bottom one here. So it'll be 2 times 5 plus 5, which is then just the 15. Okay? And then the limit as x approaches negative 5. That's going to go then in which piece? The top piece, right? Because that's less than 1, right? Negative 5 is less than 1, so we plug it in there. So you get negative 5 squared minus 5, which is going to be then just 20. You simplify that. Okay? So there you can see a little bit of the importance, right, of the left and right hand limit there. Okay, the difference that makes, especially in the piecewise, right? So just look out for that. All right, any questions on this? Miabel, does this make more sense now? Yes?
A little.
Okay, anything you still want to ask about? Any
No, I'm okay.
particular question? Okay. Anything else? Anyone else? All right, so then go to those papers that I just passed out to you. Okay, those graphs. We're going to look at these. Okay, because we're also going to examine one-sided limits with, and I know, we're going to make sure it's oriented right there too, right? So let me do it. Let me make it easy here. We'll say there's our x, there's our y, there's our x, there's our y right there. Excuse me. Okay, so let me make sure here. I've got what I want to say. There we go. All right, so let's say this is f of x that's graphed right here. So it's like a piecewise graph f of x right here. We'll put little arrows at the end too, just because, just kind of show the behavior there. And then we'll say the graph down here is the graph of g of x. Okay, we'll say this is the graph of g of x. Again, all together it's the graph of g of x. Okay, and again we'll put little arrows at the end just to show that it's going to go on forever there. Okay. So let's focus on the first one here, though, and then we'll get to that second one as well. All right, and so I'm just going to make some questions up for us here, and you guys can kind of think about them for a little bit, and then we'll get some answers. So, for example, what is the limit as x approaches 1 from the left of f of x going to be? Okay. So if we're approaching 1 from the left, according to our graph here, what y value are going to be approaching as we approach 1 from the left on our function? Okay, so, Ramike, what do you say? Negative what? Be careful. Negative 1 is right here. And we're approaching 1 from the left. So here's 1. Okay, to the left of 1, that's this piece of the graph. Right? And so we're actually, from the left, we're approaching that negative 2. Okay? Negative 2. Okay? But then, Ramike, if we're approaching the limit as x approaches 1 from the right, if we're approaching f of x or 1 from the right in our function, now what would the y value be? Now it's going to be that negative 1. Exactly right. Okay, approaching from the right-hand side here, we do approach that negative 1. Okay. And then what would we say the overall limit is? The left-hand limit, as we approach 1 from the left, negative 2 is our answer. As we approach 1 from the right, negative 1 is our answer. then we'll say the overall limit is what? Does not exist, right? Because again, the left and right hand limits don't agree. Okay? So let me give you 3 to try here. So we'll say for the limit as x approaches -1 from the left of f of x, find that. And then the limit as x approaches -1 from the right of f of x. And then the limit as x approaches -1 of f of x. And also f of -1, please. Okay, so you got 4 things there to try. And then we'll do 3 other little questions, and then we'll be done. Yes. But just a little bit more. Not much. Not much more.
Mr. Wood.
Yes.
I know. I'm
So what's that?
so lost.
Cooper, why aren't you asking questions when I ask for questions?
I don't know. Like, so I know this is from the left.
Uh-huh.
So it's for this one.
Uh-huh.
So it's for like that.
Uh-huh.
So how do you figure out what the f of x is?
So where's x equal -1? Right there. And so as you're approaching -1 from the left, -2 is your answer. That's right.
But then we just do that right here.
We approached +1 from the left there, which is also the same thing because it's all horizontal there. So all the y values are the same.
But what about this one? What about this?
What about that one?
How come that
What are we?
doesn't apply to that?
Because we're approaching 1 from the left. If that's 1 from the left, it's governed by this piece of the function. If we're approaching 1 from the right, 1 from the right, that's this piece of the function.
If we're approaching 0 from the
If we're approaching 0 from the right, you're going to go from here, but then you jump down to here, and there's 0 from the right there.
So what's this right here? 2?
That's 2. X, when x is 2. But you're not asked about that.
Okay.
Okay?
Yes. You're like. But then you were right. So.
So, anyone still need more time? No? All right, so then number 4, what do we say is our answer there? What happens, what's the limit as x approaches -1 from the left? It is not toot. It is -2, that's right, okay, -2. Okay, so again, there's -1, right? As we approach -1 from the left, we're approaching along this piece of the curve, and so it's just a y value of -2. What about as we approach -1 from the right? What are we approaching? From the right. Also -2. What's the overall limit? -2. Okay, this limit exists because the left and the right hand are in agreement, so it is that. But what is f of -1? +2, right? If we try to go down towards the graph there, we have a hole, but above it, we've got that point right there, okay? So, is the function continuous at -1? The function's not continuous at -1, right? Because even though the limit exists, the limit and the function are different values, right? The limit's -2, the function's +2, so then overall the function's not continuous there. Yes, Cooper?
Why is number 7 2?
Why is number 7 2? Okay, so this time we're asking the question, what is the value of the function at -1? Not approaching, at -1, when x is -1.
Okay.
Follow me? And so is that enough, or do you need me to show
Yeah,
more?
but why can't it be -2?
Why can't it be -2? Because what happens at the -2, we have an open circle. So at that very instant, nothing. Okay? All right, scooting up here, we got just a little bit more I want to do, and this is going to incorporate both f and g, okay? So for example, if I wanted to, I could ask you to evaluate something like this. The limit as x approaches 0 of f of x plus g of x. Okay? Remember, I was talking about this with Julia earlier, right? When you have a sum, when you take the limit of a sum, you can then just take the limit of the individual parts and add your answers together. So in other words, we can evaluate this by just doing the limit as x approaches 0 of f of x plus the limit as x approaches 0 of g of x, right? So this is equal to this. Okay, they're saying the same thing. So what is the limit as x approaches 0 of f of x? 2, right? And what's the limit as x approaches 0 of g of x? So that's this other function here, right? As we're approaching 0 from the left and from the right, we both go to 3, so 3. And so it's going to be 5 overall is your answer.
Yeah, it should be -2.
Ooh, you're right, -2. Mr. Widd. 1 is your final answer there. Okay. Juan. Okay. How about, let's do another one here, number 9. We'll say the limit as x approaches 1 from the right of f of x plus g of x all over 3. Limit as x approaches 1 from the right of f of x plus g of x all over 3. Well, again, we can evaluate the individual f and the individual g, add them together, and then divide by 3. Okay? So what is the limit as x approaches 1 from the right of f? It's -1, right? -1. As we approach 1, +1 from the right there, we're coming along this curve, and it hits there, so -1. So this equals -1 plus, and what is the value of g as we approach 1 from the right? 1, right? As we approach 1 from the right here, we're now approaching a y value of 1 all over 3. So you get 0 over 3, or just 0. Okay? And then one more here, and this will be the last one. Actually, let me ask, are there any questions up to that point? Any questions? I know I'm kind of blowing through these here, so maybe I should slow down a little bit. Any questions? Yes, Ramike. For g of x? Okay, so here's x equals 1. Okay, look to the right of it. Right to the right, that's this part of the function. So as we approach from the right towards 1, we're going down, 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 on down to the y value of 1 there. Okay.
So what if there's going to the left?
The limit as x approaches 1 from the left of g of x,
Yeah.
then from the left of 1, we're looking at this part of the graph, and so it's going to be 2 as we approach 1 from the left. It'll be 2.
Okay.
From the left, right? There's the 2. Yes, okay?
Yeah.
Okay. Last one here we'll look at is g of f of x, like so. Limit as x approaches -1 of g of f of x. Okay. So here they're nested, right? We're going to work from the inside out. So in other words, we're going to look at the limit as x approaches -1 of f. And what is the limit as x approaches -1 of f? It's going to be -2, right? We established that earlier, so that means we just need to find g of -2. And what's g of -2? It's going to be Looks like maybe like -1 or so. I'm going to say that's -1. Okay, there's -2, so about here, you know. So I'd say about -1 there. Okay. Questions on any of that? Okay. So what I've got for you then, it's on Google Classroom is your quiz review. Okay, that's it. All right, so I'd suggest you get that Google Classroom open there, start looking at the quiz review. Okay, it's like a front and a back of a piece of paper. Of course, it scans, so it's really 2 pages, right?